7 last time? Okay, let's start with question 8. Guys, everyone in the back. Let's start with question number 8. We done with it? We did 7 last time. So, the discussion that we were having last time was about multiple observations coming out of the same random variable, multiple instances of the same random variable. That is why the expected value and the variance remains the same no matter how many instances you observe. So this is another question relating to that. So rods of length 2 meter and 3 meter selected random with probabilities 0.4 and 0.6. So let's say the random variable, find the expectation and variance of the length of the rod. So let's say the length of the rod becomes the new random variable and it takes the values 2 and 3. And the probabilities, expected probabilities are 0.4 and 0.6. So this random variable takes only 2 values to it. So maybe there's like a huge inventory where you have many rods placed and they are all either of length 2 meter or of length 3 meter. These are the only 2 types of rods that you have in the inventory, because see, the total probability is the one that means there's no other rod, just 2 meter rods and 3 meter rods. So can you find the expected value? That means at an average, if I were to pick a rod, at an average what length of rod would I get? So that's how you get to see the expected value. So expected value of the length would be multiply each value with its own probability. What's the answer? 2.6. 2.6 meters is the expected value. And what's the variance? For the variance, I guess we need to find E of x square. E of L square minus E of L whole square. For L, E of L square, you need to take the square of the length. The probabilities remain the same. E of L square should be 4 times 0.4 plus 9 times 0.6 minus 2.6 squared. You should get the variance. Your point? So this part is basically your expected value of L square. Are we good? Okay. Now this was simple. 2 lengths are now selected at random. Find the expectation and the variance of the sum of the 2 lengths. Now it's the same rod from the same inventory that we are selecting. So no matter what rod comes out, the expected value of the length is going to be the same. So the idea is 2 lengths are now selected. Find the expectation variance of the sum of the 2 lengths. Now in part B, let's call that random variable, the new random variable x, and x is basically L1 plus L2. So I won't call it 2 different random variables x and y. I'm going to call it L1 and L2 because they're coming from the same random variable. They're 2 instances of the same random variable. 2 observations from the same probability distribution. So expected value of the sum would be expected value of L1 plus L2, which we know would be the expected value of L1 plus expected value of L2. Now, as both are coming from the same random variable, so the expected value is the same, so it turns out to be 2 times the expected value of the length of the rod. So it's 2 times 2.6. See, two instances coming out of the same random variable. It's not, okay, I took one from one random variable and then I went to another one which is totally independent, a totally different scenario, and I took out one random variable, one instance from that, and I'm adding two independent x and y random variables together. So x has its own expectation, y has its own expectation. No, I'm two rods from the same inventory. So the expected value of any rod that I pick is the same. So they're just two instances coming from the same random variable. That's why I'm labeling it specifically as L1 and L2, not x and y, two separate. L1 and L2 to remind us that it's coming from the same random variable L, length of the rod. So expected value of L1 plus L2 would then be expected value of L1 plus the other one. Now as both are equal to 2.6, so it's like 2 times the expected value of L, the random variable. Same goes for the variance. Variance of x would be variance of L1 plus L2. It would be the same as saying variance of L1 plus variance of L2. Now as both variances are same, it is 0.24. So we can in other words say this is 2 times the variance of L. Because they both are same. Variance of L1 is the same as variance of L2, which is equal to variance of L. No matter how many instances you pick, you're picking from the same random variable. So this is 0.48. So see, you have to read the question and judge whether the random variable that they're talking about, now the multiple random variables they're talking about, are they independent, different random variables? Independent तो ये नहीं है. One length is independent of the other, but the point is they're coming from the same random variable. It's from the same family. They're not two different situations. That's the point here. Are we good? Okay. Three lengths are now selected random. Find the probability distribution of y, the sum of the three lengths. Now, can I just clear this up? If we are all done with this. Any questions regarding part A? Okay, so let's clear this up. So let's form a table for three random variables. 3 rods selected. See, now you understand why this would be an appropriate method to take, and to understand that instances are coming from the same random variable. You just understand the application of it. If we didn't know this, it would be such a pain to find out the expected value of the variance for multiple observations. यहाँ तो सिर्फ 3-4 है. What if the observations are like 20-25? Then would you be like chalking out all the possible values of the random variable and then finding out the probabilities and then going about it? See, you'll understand right now the crux of it. Find the probability distribution of y. Okay, what is y? Y is 3 lengths selected. So it's a sum of 3 lengths L1, L2 and L3. Let's say I don't know how to get the expected values with. Right now, by the way, he's asking for the entire distribution. So if he's asking for the entire distribution, the distribution of y, what would be the values here? Now see, this is how it goes. What possible values of the sum of the lengths that you can get from an inventory that has two kinds of rods, 2 meters and 3 meters? What's the minimum? If I select three rods from that randomly and I place them and say, what's the minimum sum that I can get? It would be when if I get the shortest ones, all 3 of them are the shortest ones, 2 and 2, right? Okay. So that's the minimum value L1 plus L2 plus L3 can get. Do we all agree on this? If I get all the 3 rods, the shortest ones, 2 to 2 meters. Is everyone with me till here? Anyone who didn't understand? So there there is a hole, imagine a hole, go down, filled with rods, let's say, for or practical, infinite number of rods. It doesn't make a difference यहाँ पे 4-5 rod को उठा लो, the total is just a lot. So they're just mixed, 2 meters and 3 meters ones are mixed in it. So in this ratio, by the way, because these are the strict probabilities that we have, 0.4 and 0.6, that means if there were 1,000 of them in the inventory, you would have 400 of 2 meter ones and 600 of, that's the probability that is telling you. If 10,000 पड़ी है तो 4,000 वो होंगी, 6,000 the other one. Okay, so now you randomly pick 3 and just place them together. So to judge the total length, 3 side by side place करके, and what's the total length? So 3 lengths added. So I'm saying if I want the shortest length, how would I get the shortest length? I want the shortest one, which is the 2 meter one. So 2, 2, 2 would give me your new random variable y is the sum of the 3 lengths. So what is the smallest value that this y can take?
6.
2 plus 2 plus 2, 6. Okay, so one value is 6. What's the one after that?
7.
It would be 2, 2, 2
3.
and a 3. That's a 7. And what would be after that? 2, 3, 3, 8. And what would be the biggest sum that I have? 9. All 3 of them being 3, 3, 3, right? That's the largest value. So do you see these are all the 3 values that y can take? Tell me if there's any value less than 6 or any value more than 9.
No, sir.
There is no value. Okay. So we are done. These are all the 4 values that y can take. Y is a new random variable which is the sum of 3 lengths. Okay. Now, can you give me their respective probabilities? How would you get the respective probabilities when you know the probability of knowing the fact, I'm just going to write it here, knowing the fact that the probability of a 2-1, probability of length being equal to 2.4 and the probability of a length being equal to 3, considering this, what is the probability for getting a value 6? 0.4? Yes. How did you manage to get a 6? You got a 6 by taking 2. Okay, I'm going to write 2 and a 2 and a 2. 3 2's. Add means 0.4 into 0.4 into 0.4. Do we agree on this? So, I mean, I'm just writing 0.4 cube here. You know it's what it is. Yeah, chalo mujhe bata do what it is. 0.064. Okay, let's just write it down. 0.064. That's 0.4 cube. So I'm just indicating the fact over here that this is 0.4 cube. How did you manage to get a 7? You got a 7 by taking a 2 and a 2. Okay, but not in this specific order, in any order. So there's like 2 to 3 भी हो सकता था, it could have been a 2 3 2 or a 3 2. So there are 3 of them basically. So what's the probability for this particular one? 0.4 into 0.4 into? 0.6. So that would be 0.4 square into 0.6, but there are 3 of them. So times 3. 2 2 3, 2 3 2 and 3 2 2. So I'm going to take all 3 possibilities. It would be either a 2 2 3 or I could have gotten a 2 3 2 or I could have gotten a 3 2 2. 3 item. Right? Is everyone with me till here? Anyone stuck? Okay. Because if you understand this question, you'll understand the whole idea behind the multiple observations and why we are taking that and how it makes life easy. I'm doing this because consider the fact that I don't have that knowledge. This is exactly what I will have to do pura baith ke. I will have to do this entire exercise just to get that damn expected value of the 3 lengths together. If I don't have the knowledge of multiple observations and adding them up. Okay, so 8 would come from 1, 2 and 2 3's. So this is 8 is basically 2, 3, 3. And that would be 0.4 into 0.3 square times 3. Again 2, 3, 3, 3 times 3. Oh, sorry, yeah. 0.6 square times 3. What's the answer for this one, by the way? Exact? 0.288 exact, and this one? 0.432, and 9 is 333, and there's only one instance of it, 3, so that's 0.6 cube. 0.216. Okay. Now, if I find the expected value of this, I would do 6 times 0.064, 7 times point. Achha, the answer to part C is done. You got the probability distribution. Now the next question is, next part is, get the expected value y. Now, if I don't have the knowledge that these are coming from 3 instances of the same random variable, I will have to first build this entire table and now do the entire process of multiplying 6 times 0.064, 7 times 0.2888, and pura baith ke I will have to do this and then get the answer at the end. And you'll get the answer. But knowing the fact that this random variable y is a sum of these 3 which come from the same random variable length, so I know that for part D, if I am being asked to find the expected value y, all I know is that this would turn out this, which means this is 3 times the expected value of the length. I don't have to do this exercise entirely. I already have the expected value of length, which is 2.65. So all I need to do is just make it 3 times 2.6, which is how much? 7.8. 7.8? Exactly. Now, if you were to, by the way, you can do this in the calculator. 6 times this, plus 7 times this, plus 8 times this, plus 9 times this, add them up, you should get exact 7.8. वो मैंने question में इसलिए डाला so that I can talk about it. So now you can verify. You don't have to. You can just go to the calculator and check. Are we getting 7.8? Yeah. So see, that's why I'm saying the knowledge of multiple observations coming from the same random variable is important. It will save you from this entire exercise. Now you know finding the variance is more tedious. First you have to find E of L square and then do the whole process. So now we know that variance of y would be variance of L1 plus L2 plus L3, which would be 3 times the variance of L. Right? And that's 3 times kya tha? 0.24. Now, you can do this at home. You can do this at home. Take the square of each of them, multiply, get E of y square first, and then subtract 7.8 square from it. You should get 0.728 million. Now just imagine these were not 3 lengths, and these were like 10 lengths that you were getting from the observation. Just imagine the size of the table, considering all the possibilities of those 10 lengths, all the possible values of the random variable y, which is L1 plus L2 plus L all the way till L10, and then, yeah. Then God help you with the expected value and the variance. Are we good? Now do we understand the concept? Is everyone okay with it? At the back, are we good? Okay. Can we move on?
Yes.
People are wondering. I know some people are. So,
How does it look like? Guys with photos.
I think it's
The pyramid shape.
like something like yeah, because you throw it and land on a triangle face, it has three sides to it. Pyramid shape. Yeah, it's a tetrahedron. It's a tetrahedron. A tetrahedron is a pyramid with a triangular base. Okay. Make a probability distribution of x. So let's do that. So x would have values 1, 2, 3, and 4. Guys, shh. And the probability would be 1/4 for all of them. It's a fair tetrahedral die. All the probabilities are the same. Expected value is 2.5. Get the variance as well. For the variance we need to x square. Guys, confirm 1.25 variance? 1.25. Now see part B. Sum of the two numbers obtained when the die is thrown twice. Same die being thrown, two instances being recorded of the same random variable. So I will not call it y and z, I'm going to call it x1 and x2. Because the expected value of x1 is the same as the expected value of x2. Variance of x1 is the same as the variance of x2, which is equal to 2.5 and 1.25. So he's throwing the dice twice. S is a sum. So I'm going to call it x1 plus x2. And the expected value of S would be 2 times the expected value of x. Means E of x1 plus E of x2. 2.5. Okay, so that would be, is that a 5?
Yes.
Yeah. And the variance of S would be variance of x1 plus x2, which is 2 times variance of x, and that's going to be a 2.5. Are we good? Any questions? Double the number of which the die lands when it's thrown once. But these are not multiple instances. It's the same random variable, you just doubling the value. So part C is D means 2 times x. That's it. That's all he's saying. So you know expected value of D would be expected value of 2x, which would be 2 times expected. Now there is a reason why these two parts I want to create a distinction between. I'll just show you the point that I'm trying to make here. This is 2 times 2.5, which is a 5. But when you talk about variance of D, that would be variance of 2x, which is 4 times variance of x. Now see, please observe that this is very different from this. This is the point I'm trying to make. Please don't confuse x1 plus x2 as being 2 times x. 2 times x and x plus 2 are two different things altogether. In the world of random variables, these are two very different things. 2x is taking one instance and doubling it. x1 and x2 are taking two independent instances from the same random variable. It's very different. See, it doesn't make a difference to the expected value, it makes a marked difference to the variance. Now here the variance is 2.5 and here your variance is going to be? Is going to be 5. So you have to be very careful in the question where you have to add the multiple instances and where are you taking a multiple of the random variable. Summing multiple instances is not the same as multiplying the random variable.